Hello everyone, just let me check that stream is working or not, then I will start. Give me a moment. Yes, so stream is working. So as you know, we are discussing P1 chapters. Today is the last session of P1 chapters. From next class onwards we will be discussing P2 chapters. In the last session of P1 we are going to discuss thermal properties, thermodynamics, simple harmonic motion, kinetic theory of gases and waves, all chapters in this session. So without any delay, let us start with the session. Hello Sanjana, how are you? So let's start with the first question. Question number 1. So let's read the question first. Which one of the following VMT graph, not VM, actually it is nu-m, this is frequency, nu-m-t graph perfectly for perfectly black body, nu-m is the frequency of radiation with maximum intensity, T is the absolute temperature. Which of the following graph correctly represents nu-m versus T graph? Okay, so it actually related to Wien's displacement law, which states that for a perfectly black body, lambda m, that is maximum wavelength at maximum intensity into temperature of the object, is equals to constant. Okay, so this formula is very useful because we can determine the temperature of a star using this formula. Okay, temperature of a star is determined using this formula, so that formula is very important. But here they have not asked you about the wavelength, they asked you about frequency. So how to convert wavelength into frequency? So to convert wavelength into frequency we have to use nu-m, C upon nu-m into T equals to constant. Why? Because we know that lambda is equals to C upon frequency, right? We already aware of this equation because we have used this equation in dual nature of radiation and matter a lot, right? So wavelength is equals to speed of light, speed of wave divided by its frequency. For black body radiation, obviously it's emitting light or electromagnetic waves, so it is C by nu. And for maximum wavelength it will be maximum frequency, right? So if you write it here, just let me change one thing because you might be confused. Let me rename this constant as K. Okay, let me rename this constant as K. Now what? Now just simply reorganize. You will see that K into nu-m equals to C into T. Okay, or if you plot, you are plotting temperature along x-axis and nu-m along y-axis, so you can write nu-m equals to C upon K into T, or y equals to some constant A into x, right? So y is equal to ax. So what is this equation represents? This is an equation of a straight line passing through origin. This is an equation of straight line passing through origin. Which of the line here is a straight line passing through origin? Hello Arvind, hello Dhanashri, hello. So now tell me, which of the graph actually represents a straight line passing through origin? Only one graph is here which is representing a straight line passing through origin. So remember how to approach a question. If you know the formula, write it down and then try to relate to the given equation. And then graph based questions, always try to find the equation. If you can find equation, it's very good. Okay, so here if you see that this line represents a straight line passing through an origin, so that means correct answer is option C. Okay, option C is correct. Hello, hi. Now next question. Water is heated from 0 degree Celsius to 10 degree Celsius. Then its volume increases, first decreases and then increases, decreases, does not change. Okay, so when you heat water, what happens is that the water's volume initially decreases up to 4 degrees Celsius. Okay, up to 4 degrees Celsius. From 0 degrees Celsius to 4 degrees Celsius its volume decreases, then it starts increasing again, because at 4 degrees Celsius the density of water is maximum. This is called anomalous expansion of just a second. This is called anomalous expansion of anomalous expansion of water. So water expand anomalously compared to other objects. For example, any objects, if you increase its temperature, it will always expand, okay, no matter what. But for water, from 0 degrees Celsius to 4 degrees Celsius, something opposite happens. Its volume decreases. Instead of increasing, it decreases. This is very specific to water only. If any other object is mentioned in the question, then you can directly answer increases, but for water it first decreases and then increases. So correct answer is option B over here. Okay, now next question. A cup of tea cools from 65. Today not many of you are responding. Rohan Srivastav is saying P naught. What is P naught, Rohan? Rohan Srinivas. What is P naught? A cup of tea cools from 65.5 degrees Celsius to 62.5 degrees Celsius in 1 minute in room temperature at 22.5 degrees Celsius. How long it will take to cool from 46.5 degrees Celsius to 40.5 degrees Celsius in the same room? Now this is a Newton's law based problem. Okay, Newton's law of cooling, which states that the rate of change of temperature, okay, with time, okay, is actually constant into the mean temperature of these two, minus the surrounding temperature. This is the formula. Okay, now what is suppose the mean temperature for case 1 is T1, okay, and mean temperature for case 2 is constant, is same. Suppose this is for number 1. For number 2, okay, it is, say the mean temperature is T2 minus T0. Now if you divide these two equations, you can write dt upon dt 1 by dt upon dt 2 equals to T1 minus T0 by T2 minus T0. So if you can find the value of T1 and T2, dt by dt is already given for case number 1. For case number 2, dt is given. You are trying to find the temperature time difference. Okay, so let's do it part by part. First let us find what is dt by dt1. It is nothing but difference in the temperature, that is 65.5 minus 62.5 divided by the time taken, here 1 minute, so it is 1. So it will be 3 by 1, that is 3. So dt by d1 is actually 3. What is T1? T1 is the mean temperature of the same temperatures. So it will be 65.5 plus 62.5 by 2, which is 128 by 2, which is 64. Okay, now what about T2? T2 is mean temperature of these two. Mean temperature of these two is 46.5 plus 40.5 divided by 2, that is 47. 77 by 2. 77 by 2 means 37.5. No, sorry, 47.5. It will be 87. 87, right? 87 means 86, 43, 43.5. Okay, it will be 43.5. Now what about dt2? Change in temperature. Change in temperature is simply 46.5 minus 40.5, which is equals to 5 degrees. Okay, 6 degrees. Now we will go back to our this equation and we will put the values. dt by dt1 is 3, dt2 is 6, and dt2 we trying to find. This time we are trying to find. What is T1? T1 we have calculated is 64, okay, minus 22.5, which is given in the question. T2 is given 43.5 minus 22.5. Okay, now simplify. So it will be 3 dt2 divided by 6, that is half, and we get on this side we get 41.5, right? If I am not mistaken, 41.5 divided by 21, divided by 21. Okay, so it will be dt2 will be equals to 41.5 into 2 is 83. 83 by 21. 83 by 21, which is roughly approximately 4. Okay, so it will take 4 minutes. 4 minutes will be answer. Now how it is 4 minutes? Because 4 into 21 is 84. 4 into 21 is 84. Here we have 83. So the closest whole number is 4. So correct answer will be 4 minutes. Be careful on this kind of question. You have to remember that you have to find the mean temperatures, you have to find the temperature gradients, etc. But this kind of problems are very, very common in KCET, and it used to come almost every alternate year. Now it did not come about 2-3 years, but it used to come almost every alternate year. So if this question comes, you should be able to solve it. Which of the following curves, yes, which of the following curves represent the variation of coefficient of volume expansion of an ideal gas at a constant pressure? So which graph represents the variation of volume coefficient with temperature? Okay, volume coefficient for an ideal gas is actually 1 by T. Okay, so if this is y, this is x, then it will be a straight line passing through origin. So alpha v versus 1 by T will be a straight line passing through origin. So correct answer is this. Okay, don't confuse that. Okay, alpha t is 1 by T, so that means it will be a constant. It will not be a constant graph. You need to always try to find the graph. Okay, you need the, the equation, you need to find the graph. You can easily answer the question. Okay, let's see how many of you have answered it correctly. Okay, 50-50. Some of you have answered this. Now this one is not correct. Why? Because here we have a T variation. Okay, with respect to T, if you plot the same graph, if for example, if you remember Boyle's law, PV equals to constant. So P equals to constant by V. So PV diagram was a rectangular hyperbola. Okay, it is not a straight line graph. So if you plot alpha v versus t, that graph here, for example, if you plot this graph, it will be like this. Okay, it will be like this. Okay, alpha v versus t graph will be a rectangular hyperbolic graph, not straight line graph. Okay, alpha v versus t graph will be a rectangular hyperbolic graph. Okay, now let's move on to the next question, question number 5. A solid cube of mass m at a temperature theta naught is heated at a constant rate. It becomes liquid at temperature theta 1 and vapor at temperature theta 2. Let S1 and S2 be specific heats in its solid and liquid states respectively. If LF and LV are latent heats of fusion and vaporization respectively, then the minimum heat energy supplied to the cube until it vaporizes. Now the question language is very long, but answer to this question is very easy. So who can answer this question? Hello Vidya. Okay, so what will be the answer to this question? The language of this question is very long, so let me break it down for you. So first of all we have a object at a temperature theta naught. Okay, we bring it to a temperature of theta 1. Okay, this is solid. Now after this state it becomes a liquid, okay, of temperature theta 1. So basically it melted. Okay, for example, suppose you have a water at minus 10 degrees Celsius. You brought it to 0 degrees Celsius. Then it melted into water at 0 degrees Celsius. Okay, then you put it into a water of say theta 2, which is say 100 degrees Celsius. And finally you vaporizes it into gas, okay, at theta 2, that is 100 degrees Celsius. So this is the process which is happening over here. You have to find the total heat required for this stage. The specific heat here is S1, the latent heat of fusion is LF, here specific heat is S2, and here latent heat of vaporization is LV, I think. LV is given? LV is given. Okay, so this is the process which is happening. Now you have to find the total heat required. So what is the total heat required from here to here? Total heat required is m s theta delta theta. Delta theta means change in temperature. Okay, so it will be always higher temperature minus lower temperature plus now you have to add the latent heat of melting, which is MLF, plus now you have to again add the heat which is required to heat the water. So MS2, now the final temperature is theta 2 and initial temperature was theta 1, so it will be MS theta 2 minus theta 1. And last but not the least is that it is melting, it is vaporizing, so MLV. Okay, so the latent heat, if latent heat is given, then mass into latent heat is the heat required to change the state. For any other case, when you are just increasing the temperature, it will be ms delta theta. Okay, ms delta theta, that is the formula for heat increase, and for melting or vaporization the formula is very simple, ml. Okay, so here we have two states where it is increasing the temperature and two states where it is changing the state. Okay, so correct answer will be obviously this one. Now if you see this one, almost same, except here there is a theta naught given. So both are theta naught. Okay, so obviously this is the from minus 10 degree to 0 degree Celsius. So this means this is minus 10 degree Celsius. Here also it is 100 minus 10 degree, which is not correct, right? It has to be the intermediate temperatures, which is theta 2 minus theta 1. So correct answer is this one. Otherwise other options, they lack one or two options, that means it is incorrect. Okay, so make sure even if you have solved it, you in the heat of the exam you might make a mistake that you actually incorrect your answer, right? So make sure that you have answered this correctly. Again, some of you have answered A. Why you answered A or B? A or B has nothing to do with it. M does not have the heat required for increasing the temperature of solid. Okay, here it does not have any latent heat added here. Okay, latent heats are not added at all. So latent heat, you have to add the latent heat as well. So correct answer is option C, not A, not B. Okay, now next question. 3 metal rod, this is a question from 2025. Okay, this question came in 2025. 3 metal rods of same material and identical in all respects are joined as shown in the figure. The temperature of the ends of these rods are maintained as indicated assuming no heat energy loss occurs through the curved surface of the rods, the temperature of the junction X is. So here we have a junction X. Okay, so if you see the diagram carefully, you will see that here we have 90 degrees Celsius, here also 90 degrees Celsius, here we have 0 degrees Celsius. So some heat is coming from this side, some heat is coming from this side, and combined heat is going in this direction. Obviously heat will flow from higher temperature to lower temperature. Heat always flows from higher temperature to lower temperature. The temperature of this junction Tx must be in between 90 and 0, right? Now if you see, because all the rods are identical in nature, lengths are same, so we can say that if heat is coming here, say H, the same amount of heat will come from this side as well, and total heat that is passing through this will be 2H. Okay, if you remember Kirchhoff's current law, it is very similar to Kirchhoff's current law. Okay, conservation of energy here. Okay, because heat is energy, so total energy has to be conserved. So whatever heat is coming from this side, whatever heat is coming from this side, they has to add up, and total heat should be 2H. Now what is H? Now for a conductor, heat passing through it is, for a conductor, heat passing through is actually proportional to difference in temperature. Okay, difference in temperature, so T2 minus T1, right? So in this particular case, we can say that H is actually equals to some constant K into 90 degree minus Tx for the first two cases. Okay, 90 degrees minus Tx, 90 is higher, Tx is in between. So 90 minus Tx into some constant, because everything else is area, length, everything else, material, everything is constant. So here it must be proportional to this value. So what about this heat? Now this H and this H are same. What about this heat? 2H. 2H, here it is starting at Tx going till 0 degree. So 2H must be equals to K into Tx minus 0. Any doubt? Okay, why? Because for the first rod, for these two rods, 90 degrees here, Tx here. Okay, so for this it will be 90 minus Tx. This is also same, so 90 minus Tx. And what is here? Here it will be Tx 0, so it will be Tx minus 0. Okay, now as we have done calculation that if this heat is H, this heat is H, then this one must be 2H. So we have used it. Now we will use this H value over here. So 2 into K into 90 minus Tx equals to K into Tx. K cancels, and we get 180 minus 2Tx equals to Tx, or 180 equals to Tx plus 3Tx, 2Tx, 2Tx, that is 3Tx. So Tx must be equals to 180 by 3, which is 60 degrees. Okay, so the temperature of X is 60 degrees Celsius. Right, now let's move on. The efficiency of a Carnot engine which operates between the temperatures. Okay, let's check the answer for question number 6. Who all you have answered correctly? Again, lot of you are making mistake. Bhagya, not C. Make sure you are answering properly. Carnot engine not there. Carnot engine is there, Siddhant Nayak. Carnot engine is there. Okay, the efficiency of Carnot engine, the working of a Carnot engine, it is there. If you think it is not there, then you are wrong. Carnot engine is not deleted. Okay, in the second law of thermodynamics, the refrigerator is deleted. Refrigerator is not there, but Carnot engine is there. Okay, if you think that Carnot engine is not there, and if you don't study, then you might later on you might be thinking that okay, I thought Carnot engine is not there, but in the exam it came, then you will cry. So make sure you understand which are there, which are not there. What is the efficiency of Carnot engine? Efficiency of Carnot engine is 1 minus cold temperature by hot temperature. Remember that, cold temperature by hot temperature. Efficiency cannot be negative. Remember that, efficiency cannot be negative. So 1 minus the cold temperature given here is 300, and the hot temperature is given here 500. So it will be 1 minus 3 by 5 or 2 by 5. Now this is fraction, so you have to convert it into percentage. So that means you have to multiply by 100. So 20, 40%. So the efficiency is 40%. Okay, efficiency is 40%. Yes, Bhagya is correct. Tanishk is also correct. Right? Easy question, not difficult. No difficult question will come, but easy questions will still be coming. Okay, also you need to remember one more formula, that is T2 by T1 equals to Q2 by Q1 in terms of heat. This is in terms of temperature, this is in terms of heat. Okay, this is also very important formula. You can exactly replace this formula over here to calculate efficiency. Sometimes they will ask you what is the heat between the cases. So that is also important formula. Okay, now calculate the work done here. Okay, work done in case of PV diagram is area under the graph. It is the area under the graph. So you need to calculate the area under the graph, which is easy. So what is area under the graph? Half difference in pressure into difference in volume. Very simple. This is the work done in case of a cyclic process. So if you see that here, the work is here, here, and then here. Okay, so it is basically going in this direction, so the work done will be positive. Work done will be positive because it is going in anti-clockwise direction. If it is a clockwise direction, work done will be negative. Okay, now let's see. So it will be half into difference in pressure is 400 minus 100 into delta V. Delta V is 10 minus 5, that is half into 300 into 5, which is 150. 150 is 750. So 750 joules is the correct answer. So option B is correct. Okay, option B is correct. Yes. Hi Chetan. Yes, correct. Correct. Everyone is correct. B is correct answer. Now next is, this is very interesting question from 2021. A number of Carnot engines are operated at identical coal reservoir temperatures TL. However, their hot reservoir temperatures are kept different. A graph of the efficiency of the engine versus hot reservoir temperature TH is plotted. The correct graphical representation is. So those who don't know, the efficiency is given by 1 minus T low by T hot. Okay, so what is the correct graph? How the efficiency is related to low and hot temperature? Interesting question. I will not tell you the answer. Try to answer. Good evening, Boxer. Isn't it because it's anti-clockwise? Yes, yes, exactly. It is because it's anti-clockwise. Tanishk is saying option A. Let's see. So if you see that, first of all, let us understand what is happening over here. If you keep this TL fixed, TL is fixed. Okay, this one you are increasing. This one you are increasing. So if you increase T hot, what happened? Suppose you are initially, suppose this number TL is say 0 degree, not 0 degree, say 300 Kelvin, 27 degrees Celsius. Okay, 300 Kelvin. T hot initially was suppose 500. Now you increase to 600. Now you increase to 700. Then suppose at some point of time you reached a stage where you said, okay, I will keep it a very high number. I will keep it say 3000 Kelvin. What is happening to this number? So as you are increasing this slowly, what happens is that this number is actually increasing. Okay, 1 by 10. And if you keep on increasing T hot, okay, the number becomes very small. So this number is decreasing. So overall this number is decreasing. So if this number is decreasing, then efficiency is slowly going towards the unity value. So efficiency initially was lower and slowly it is increasing, and not only increasing, it cannot go on increasing infinitely. It will go towards the value of 1 or 100% efficiency. That means the graph will start at a lower value and slowly the efficiency will be reaching number 1. So if you plot here, this is actually 1. Okay, so there are two graphs where efficiency is increasing. Okay, one is this one, another one is this one. But this one, it goes 1, 2, 3, 4, means efficiency of an engine increases to 200%, 300%, 400%, which is absurd. So definitely this cannot be true. Here efficiency is decreasing, here also efficiency is decreasing, and in fact here efficiency is there where the temperature is even less than TL. The engine is working. Engine will only work when the hot temperature is more than that of the low temperature. Okay, engine will not work if the hot temperature is less than low temperature. That's why the graph will start from TL. Otherwise the efficiency will be negative, and negative efficiency does not happen, so it will be 0. So it will be zero efficient. Okay, so efficiency will slowly go towards 1. So correct answer is option B, not option A. Okay, most of you have answered correctly. If you have not understood, then mention. Sir, what are the important chapters for KCET in first PUC? First year, please tell, sir. Manoj 21, Destroyer, I told you multiple times in my last class. If you really want to know the first PUC important chapter, wait till the end. Again at the end I will explain. Okay, during my last class I put a little bit focus on the important chapters of PU1. I will tell you once more, but right now let me finish the lecture. At the end of the lecture I will tell you the important chapters. So please wait till the end. Now, this is very interesting question. The PV diagram of a Carnot engine is shown in the graph below. This is not an easy question, by the way. The engine uses 1 mole of an ideal gas as working substance. From the graph, the area enclosed by the PV diagram is, the heat supplied to the gas is given here, 8000 joules. So here we have a PV diagram. Now you might say, sir, we know that area under the graph is the work done. Area under the graph is work done, but how can we calculate that? Okay, how can we calculate that? We have no idea what shape is it. Is it a rectangle? Is it a square? Is it a triangle? It's a very odd shape. Then how can we calculate the area under the graph, right? So this is actually not directly area under the graph question. Here you have to calculate the work done in the other way around. And how to do that? To do that, you have to first find the temperature that is coming in is given 8000. Okay, and the heat that is coming in 8000 joules. You need to find the heat which is going out. If you can calculate that, then the work done or the area under the graph is the heat which is coming in minus the heat that going out. This is the work done, this is the area under the graph. Okay, but this quantity is not known. So even though it's a area based question, you cannot directly calculate the area unless you have a specific area measuring device, which is illegal and not allowed in the exam hall. So you will not be able to calculate area. But we are from physics class, so we know the physics and we will be using some physics concept. What is that? That from point A till point B, the temperature is constant. From point A to point B, temperature is constant and it is an isothermal process. So A to B, it's an isothermal process. That means any point we can take, we can either take point A or point B, and we apply the ideal gas equation, which is PV equals to RT. Okay, PV equals to RT for 1 mole gas, PV equals to RT, and we can calculate the temperature T1. Okay, we can calculate the temperature T1. This is the temperature, the hot temperature. This is the point where the temperature is high. So this is temperature T1. This portion will be again another isothermal process. This process and this process, that is C2D process. These are all isothermal process. So isothermal process means this will be T2. Okay, this temperature will be T2. So temperature T2 means what? T1 equals to P1 V1 by R. Okay, what is P1? If you see at this point, P1 is 1600. What is V1? V1 is 2.5. Okay, unit does not matter because it will eventually cancel. So we will keep the unit as it is, and even R is not matter here as well. So this is T1. Now we can use the point C to calculate the temperature T2. That is P2 V2 by R again. What is this P2? P2 is 400, V2 is 6.25. So 400 into 6.25. Okay, by R. Now obviously I told you one more formula to use, that is T2 by T1 equals to Q2 by Q1. Q1 is given, so you can calculate Q2. Okay, so T2 is what? T2 is 400 into 6.25 and T1 is 1600 into 2.5. R both were in division, so they cancelled out. R cancelled out. Okay, divided by 8000. So this will be 1 upon 4. 2.5 into 2.5 is 6.25. Okay, now do the cross multiplication. So Q2 will be 2.5 into 8000 divided by 4, that is 2000. So it will be 5000. So Q2 is 5000. So Q1 supplied is 8000. So work done or area under the graph is Q1 minus Q2, which is 8000 minus 5000, which is equals to 3000. Okay, so the correct answer for this question is 3000 joules. Okay, option C, not option B, Chetan. Okay, hello Dikshita. So option C is correct. Okay, make sure you understand the problem. See, exact same question will not come, but if you understand the theory that some times we need to apply the very basic ideal gas equation. Why we are able to use ideal gas equation? Because this process is isothermal process. This is also isothermal process. So any one of these point we can apply. Now you can apply at point B also. You might say, sir, I want to apply at point B. Yes, you can do that. Okay, you will get the same answer. But point D is tricky because point D volume is not exactly given. So point D you cannot use, but you can use point A or point B and point C. Point C is where you calculate T2, point A or B you calculate T1. Okay, now let's move on to the next question. a gas is taken from state A to state B along two different paths 1 and 2. The heat absorbed and work done by the system along these two paths are Q1 and Q2 and W1 and W2 respectively. Then what is the relation? So here is your home, point A, here is your college. You went to college one day via metro, next day via bus, okay, and suppose the heat or the amount of money that you spend in case 1 is, say, work done is W1 and heat that you supplied is Q1, and this is W2, this is Q2. Now it says that what should be the relationship between these two. So gas can also take two different paths to reach the same state. Okay, same state means same temperature, same pressure, same volume, etc. So one case, suppose you increase the pressure and then decrease the volume. Second case, you increase the volume then increase the pressure. So but final state was P1, V1, T1 and final state is P2, V2, T2. You can achieve this in multiple combination. Okay, you can achieve this in multiple combination. So one combination you went this way, okay, and another you can go this way. So these two paths are taken. Now they said what is the relationship between these two. Now remember one thing, that no matter which path a gas takes to reach from one position to another, the change in its internal energy will always be same. Change in its internal energy will always be same. Internal energy change does not depend on path. Okay, internal energy change will always depend on final state and initial state. Okay, so from first law of motion, this is a first law based question. First law of motion, we know that the heat that you supply goes into two things. One is increasing its internal energy and doing some work. Okay, so internal energy is actually the heat that you supplied minus the work done by the gas. Okay, this is the change in internal energy. Now we will use this concept for case number 1. For case number 1, the change in internal energy is Q1 minus W1, and for second case it is very simple, same thing, Q2 minus W2. Because change in internal energies are same, so Q1 minus W1 must be equals to Q2 minus W2. Okay, so Q1 minus W1 equals to Q2 minus W2. So option B is correct. Option B is correct. 50% of you have answered correctly. I don't know why most of you are asking, sometimes some of you are asking, sir, increase the volume. Manoj 21 Destroyer. Manoj, I can tell you, I can vouch you that I am one of the loudest teacher in this channel. Okay, I am one of the loudest teacher. If you are not able to hear me, that means you have a problem with your device. Increase the volume or use headphones so that you can hear me clearly. Okay, it sometimes happen that the speaker of your phone may be maybe slightly not working properly, or use headphones so that you can hear me properly. Okay, or check your volume of your device. During an adiabatic process, the cube of the pressure is found to be inversely proportional to 4th power of the volume, then the ratio of specific heat is. So very interesting question. Okay, cube of pressure means not this cube. Okay, not this cube. This is a cubical shape. Cube means 3 to the power 3, found to be inversely proportional to the 4th power of volume. This is what they found. Now they ask you the ratio of specific heat. Now in adiabatic process, we know that PV to the power of gamma equals to constant. What is gamma? Gamma is the ratio of the specific heats, which is Cp by Cv. So if you can find the gamma in this case, you can actually find the ratio of specific heat. How to solve it? So first let me remove the proportionality constant by using some constant, say k into v to the power of 4. Okay, now take cube root on both sides, then you get p equals to k to the power of 1/3 divided by v to the power of 4/3, right? Cube root on both sides. Now if you take this on this side, you get p into v to the power of 4/3 equals to k to the power of 1/3, that is a constant. So now you compare this equation and this equation. Okay, so on our left hand side we have p v to the power some value, right hand side we have constant. That means gamma here must be equals to 4/3, so that is 1.33. Okay, so correct answer is 1.33. Okay, even though the question looks odd, actually it is one of the simplest problem. If you know how to solve it, you will be able to solve this question. Okay, not difficult. Yes, most of you have answered this question properly. Okay, repeated question. No, Shankar Mati Patil. I'm supposed to go to college for tomorrow 3 chapters mock test daily, it seems, but I can study by myself. Going into the college waste of time for me. What to do? The Deepti. So Deepti, it depends upon you. If you are only going to college for the tests, I recommend you should go for the test. Okay, but if the college is such a way that they will hold you, you cannot come back after the test, then better not to go. Okay, if it is something like that, only you can come back after the giving the test, then you should go, because tests are important. Time management, time practice is important. Okay, no matter what level of test they give you. Okay, so you should practice more by giving tests. Or what you can do, you can ask your friend that at the end of the college, take a picture, send the paper, try to solve the paper on your own. So both are fine. Okay, if you think that the teachers which are teaching in the college maybe not, because I know I used to teach in a college where the students which are coming into the college for CET classes, most of them are not super interested. They just came to the college to interact with their friends. Okay, I don't blame them. But anyway, some of them are serious students, but serious students used to feel that this is actually waste of time. Even though the teachers are giving their 100%, because of the students who are there after their final exam, they are now relaxing. They just go to college to chill out with their friends, and because the parents are still strict, they don't allow it to do it at their home, so they go to the college. Okay, frankly speaking, even though teachers are teaching properly, they are teaching well, you will not be able to concentrate in the class. So what you can do, but definitely you should attempt the test if possible. Tests is good. No matter what chapter they are taking, PU1, PU2, you should always attempt the tests. Tests are always helpful, no matter what. If gamma is the ratio of specific heats and R the universal gas constant, then the molar specific heat at the constant volume CV is given by. So gamma is specific heat and R is ratio, so I will give you the hint, then you solve, then I will solve again. Okay, so gamma is what? Cp by Cv. Cp by Cv is gamma, and we also know that Cp minus Cv equals to R. So basically you have to use these two equations to solve for Cv. Okay, you have to find Cv. So you have to find Cv from these two equations. Quickly solve. Only 1 hour test, then classes. Okay, so in that case, what you can do, you can, if you can attempt the first half. Okay, attempt the test, stay till first half, then during the lunch break tell them that you have some health emergency or medical emergency or something, and you come back. Okay, so first half you attempt few classes, learn few things, then you come back. Okay, that is one solution that I can suggest. okay, but don't tell anyone that I suggested it. So now let's see what is Cp. Cp is equals to gamma Cv. Okay, Cp equals to gamma Cv, right? From here, now put this value over here, gamma Cv minus Cv equals to R, okay, or gamma minus 1 into Cv equals to R. So Cv equals to R by gamma minus 1. Okay, so correct answer is R divided by gamma minus 1. So option A is correct. Okay. Option A, Suresh, no, option A, not option B. Not option B. Okay, if it is Cp, this is Cp, this is Cp, this is Cv. Okay, others have no meaning as such. Okay, this is Cp. If they ask you the same question Cp, then this will be Cp. Okay, because Cp is gamma into Cv. Cv is R by gamma minus 1, so it will be gamma R by gamma minus 1. Okay, so Cp is this, Cv is this. Okay, clear? Now next question. A graph of pressure versus volume for an ideal gas for different processes as shown. In the graph, OC represents. In this graph, what does this graph OC represents? Here we have 4 graphs, 1, 2, 3. But they actually, just to give you a context, they give the other graphs. Okay, I will tell you what this graph represents. This here is constant pressure, so this is isobaric. Bar means pressure, so isobaric process. This graph represents isobaric process. Here the volume is constant. The volume is constant. This is volume graph, volume axis. So here volume is constant. That means this is isochoric. Core means pressure, volume. Okay, so this is isochoric, this is isobaric. Now you have to identify between these two graphs. Okay, I can tell you that one of them represents isothermal, another one represents adiabatic. So this is the hint. Which book is best for PYQs of physics? Shankar Malipatil. So if you are really looking for a book for PYQ, we have a book of our own, Diksha Vedantu publication published by Vedantu, 20 years PYQs. There you will get physics, chemistry and mathematics all together, and the price is only 399. Okay, so if you just really looking for a PYQ book with solution, detailed solution, answer key, as well as a small summary of the chapter, this is the best book. Okay, and no other book you need to purchase. One book has all the subjects. Okay, otherwise if you purchase individually, one book costs generally 180 to 200 rupees. Okay, some other publications. Okay, so that books used to be 180 to 200, which is actually cost, 3 books costs 600 rupees. If you purchase it, I think it is available in Amazon. You can purchase it from the link in the from our video as well, but you can search on Amazon Vedantu KCET 20 years PYQ. Vedantu KCET 20 years PYQ. You will get it. Okay, I think in Amazon you might get it little less also. Okay, when last time I checked, it was available for less value as well. You can go and check in Amazon, you will get it, and 1 or 2 days you will get it delivered based on where you are. If you are in Bangalore, you will maximum it will take 2 days. If you are outside Bangalore, within 3 days or 4 days you will get. In Karnataka, within 3 to 4 days you will receive it. Okay. Now let's see who can answer this question. Okay, COD means C or D. Okay, you are saying C or D. Isobaric process I already mentioned, so this is not isobaric. It is available on Amazon. Yes, cash on delivery I'm not sure. So if you're asking about cash on delivery, I'm not sure, but yes, you can purchase it from Amazon. Yes, it is there in Amazon. You can search and you might get it a little better deal than this. Okay, so what is this graph represents? This graph represents, so if you see that this graph is very flat, this graph is very flat, so if you try to calculate the slope will be very low. But if you try to calculate the slope here, the slope will be very high for this graph. So any high slope graph which is very steep, this graph is steeper, okay, this is falling quickly. Steeper means the slope is very steep, you fall very quickly on this, whereas here you fall slowly. Okay, so you can consider it like a slide. Okay, when we were kids we used to slide along, right? The one of them was whoever has the steepest slide, we enjoyed that a lot because it takes a very less time to reach the ground. So this is a steepest slide. So this is adiabatic process. Remember, any steepest slide actually adiabatic process. Okay, this one is isothermal process. Okay, so option C is adiabatic. Option D is correct. Okay, option D is correct. Isothermal is flat, okay, whereas adiabatic is much steeper. You need to understand the slope of adiabatic graph is gamma times more than that of isothermal graph. So adiabatic graph is more steeper. So if you see a graph where suppose one graph is like this, another graph is like this, so definitely this will be adiabatic. This is adiabatic and this is isothermal. The graph of isothermal is actually graph of isothermal is rectangular hyperbola. Now, next question. The speed of sound in ideal gas at a given temperature T is V. Then the speed of gas molecules at that temperature is VRMS. Okay, so speed of sound and speed of gas. So it's a mixed concept question. The ratio of velocities V and VRMS for helium and oxygen are x and x dash respectively. Then x divided by x dash is. So first of all, what is speed of sound in air? Speed of sound in air can be represented by this formula from Laplace's correction, gamma RT by M. M is mass. Okay, gamma RT by M. What about speed of gas molecules? Speed of gas molecules, it is given by 3RT by M. Now remember, sound and gas both are sound is being carried by gas particles, so mass is same. Okay, sound, whenever suppose I am talking over here, it is being carried away by sound, air. Okay, then it is being converted into electrically and then it is sent to you. So basically, whenever we say that this M, mass of air molecule is same in both cases. Okay, so what is the ratio? The ratio is V by VRMS is gamma by root of gamma by 3. Okay, this is a fixed ratio. Always remember. Now what about helium and oxygen? So this ratio is x for helium. That means V by VRMS of helium. What is special for helium? Helium, nothing special, only gamma will be for helium divided by 3, and x dash is same, only thing will be gamma of oxygen by 3. So if you find the ratio of x by x dash, it is nothing but x by x dash is actually equals to square root of gamma of helium by gamma of oxygen. Okay, so what is gamma of helium and what is gamma of oxygen? So gamma is actually given by a very simple formula. degrees of freedom of the gas plus 2 divided by degrees of freedom. This is the formula for ratio of specific heats. Okay, now what is degrees of freedom? Degrees of freedom means, suppose we have a particle. How many direction it can move freely? It can move along x direction, it can move along y direction, it can move along z direction. So its degrees of freedom is 3. Okay, now what about particle which is joined, two particles, basically molecules. Okay, molecules which are joined. Now here it can move along a direction. Now there is a shortcut way to remember it, you can figure it out, but there is a shortcut way that how many degrees of freedom if this was alone, degrees of freedom is 3. How many degrees of freedom if this was alone, degrees of freedom is 6. So what is the total degree of freedom? Total degree of freedom is 3 plus 3 6, but here they are related with one another. So total degree of freedom will be 6 minus 1, that is 5. Okay, this is how you can calculate, or you can say that the rotation is there, so it can rotate like this, it can rotate like this. So from there the 2 extra degrees of freedom is coming. But otherwise, how can you calculate if two objects are related like this? So you can always suppose there is a system like this. So in that case, so total degree of freedom is this is 3, this is 3, this is 3. Okay, so 3 plus 3 plus 3, total 9, but they are related 1, 2, 3, so minus 3. So degrees of freedom of this kind of structure is 6. Okay, so it is not always gets added, you have to be careful. This is called constraint. Constraint, if you know the constraint relation, you can actually find the degrees of freedom easily. So helium is a monoatomic gas. Monoatomic gas means it has only one atom in its molecule, whereas oxygen is a diatomic gas. That means it has two atoms in its molecule. So for helium, gamma will be simply 2 plus 3 by 3, that is 5 by 3. You can remember it, or you can figure it out in this way, whatever way you are comfortable. And gamma for oxygen is 2 plus 5 by 5, that is 7 by 5. Okay, so gamma and both gammas are now calculated. Now what we are trying to find? We are trying to find x by x dash, that is square root of gamma of helium divided by gamma of oxygen, which is square root of 5 upon 3 by 7 by 5, that is 25 by 21, that is 5 by square root of 21. So correct answer is 5 by square root of 21. Okay, so option B is correct for this question. Okay, now let's move on to the next question. Pressure of ideal gas at constant volume is proportional to. Pressure of ideal gas at constant volume is proportional to force between the molecules, average potential energy of the molecules, total energy of the gas, average kinetic energy of the molecules. Easy question. Why are these questions so difficult? Because you have for P1 I am doing PYQs. Yes, Deepti, at least if you are doing PYQs, at least understand the concept through the PYQs. That's what we are doing here, so that you understand what are the concepts involved in the question. If you understand that, then your PYQ revision will be done through PYQs. Okay, revision through PYQ is one of the good way, but as long as you just memorizing the answers will not help. Understand the concept. Actually this concept is very simple. This is the concept, okay, which is actually those who are preparing for NEET and JEE, they have come across this formula more often than you have. Okay, because in for NEET and JEE, P1 has a very high weightage, unlike KCET. Okay, so they have used this formula, so for them this question might be easier, right? So now let's see this question. Total energy of the gas. Now remember that equipartition of energy states that the average energy is actually related to pressure. Okay, pressure is I think one third of energy. Okay, one third of energy, and this energy is mean energy. This is mean energy, that is half kBT. Okay, so this is the average kinetic energy per degree of freedom per molecule, right? That is equipartition of energy. Average kinetic energy per degree of freedom per molecule is given by this, and pressure is related exactly one third or two third, I don't remember, but this is the relationship between pressure and energy. So pressure is actually proportional to average kinetic energy, not total kinetic energy. In fact, total kinetic energy does not make any sense for gas. Average kinetic energy is important. Remember, for gases, average is more important than total. Okay, yes, option D is correct. Option D is correct. Right, now let's move on to the next question. The ratio of molar specific heats of oxygen is. So we just simply see, if you, that other question might feel little difficult, but if you have understood that concept, you will be able to answer this question. Okay, degree gamma equals to degree of freedom plus 2 by degree of freedom. For oxygen, how many molecules are there? We have 2 molecules. 2 molecules are like this, so degree of freedom is 5. So degree of freedom is 5, means it will be 5 plus 2 by 5, that is 7 by 2, 7 by 5, that is 1.4. So this will be 1.4. Now you can remember, for monoatomic gas it is 1.67, for diatomic 1.4, for polyatomic 1.33. Okay, that is a way to remember, memorize, or if you go by the formula, you can use the formula as well. Okay, this is the concept. This is the concept. How to memorize it, that up to you. For example, I memorize it that individual particle have always degree of freedom 3. Now this is the constraint. Constraint means they are binded by one line. Okay, one bond. So one bond means it must be 6 minus 1. So that is the degree of freedom. Always like that. 27 degrees Celsius temperature, the mean kinetic energy of the atoms of an ideal gas is E1. If the temperature is increased to 327 degrees Celsius, then the mean kinetic energy of the atoms will be. Again, if you have understood the concept of mean kinetic energy, which says that mean kinetic energy is half kBT. Okay, this is the mean kinetic energy. Now for case 1 it will be kBT1, for case 2 it will be half kBT2. kB is Boltzmann constant. So basically you are finding the division between them. So E1 by E2 is nothing but T1 by T2. Okay, so E2 will be T2 by T1 into E1. Okay, so E1 is given here, T2 is what? Now here only problem with this type of question is the student sometimes use the centigrade temperature and they totally confused. Okay, so here you have to convert it into Kelvin temperature. So 273. So 27 plus 273 is 300, and 327 plus 273 is 600. That's it. Right? Now put the values here. 600 by 300 E1, which is 2. So correct answer is 2E1. Okay. Option C. Option C. Yes. Yes, correct. Option C. Now next question. The circular motion of a particle with constant speed is. This is a very confusing question. Many of you have often confused whether it is a periodic but not SHM, SHM but not periodic, periodic and also SHM, neither periodic nor SHM. So here we have a circular motion, okay, about its axis, uniform circular motion obviously. So whether it's a periodic, question is whether it's a periodic or it's an SHM or it's both or it's not, neither of them. Okay, so that is the question. Now what is the property of periodic motion? Periodic motion is something which repeats after a certain interval of time. For example, sun rises every day after 24 hours on the east, and it sets every 24 hours in the west. Okay, so the cycle between sunrise and sunset is fixed, so it's a periodic motion. And for example, earth also rotates around the sun in every 365 days. This is also a periodic motion. But is it a simple harmonic motion? What is the condition of simple harmonic motion? Simple harmonic motion means, for example, a pendulum oscillating, it is a simple harmonic motion. Simple harmonic motion means wherever the object is, okay, there is a force called restoring force which acts in the opposite direction of the displacement. So displacement, suppose this is the mean position, so displacement is this, okay, and there is a opposite restoring force which acts in the opposite direction of the displacement. Okay, so displacement and displacement is in negative proportional to the restoring force. Restoring force is negatively proportional to the displacement. So this, from this, if this condition is satisfied, then we say this is a simple harmonic motion. So actually Fx equals to minus omega square x. You can even calculate the angular frequency. Okay, so this is the condition that has to be satisfied by simple harmonic motion. Now let's see which condition it's satisfied. So if you see that after every time it will come back to its original position, that means it is a periodic motion. Uniform circular motion is always a periodic motion because it always comes back to its starting point. What about SHM? So here if you see that, suppose it rotates from here to here, what is the direction of displacement? Direction, suppose this is A, this is B. Okay, so the displacement is in this direction, straight line path, right? What is the direction of force? Force is always acting towards the center. Force, that is centripetal force, is always acting towards the center. That means the displacement and force have no such relation like this. So this is a only periodic motion but not a simple harmonic motion. The motion is periodic but not simple harmonic. Circular motion is periodic but not simple harmonic. Okay, Chetan I think answered option D, which is wrong. Deepti, Aryan answered correctly. Okay, now let's move on to the next question. A particle executes SHM with amplitude 0.2 meter and time period 24 seconds. The time required for it to move from the mean position to a 0.1 meter from the mean position is. So the time period here is given as 24 seconds. Okay, amplitude here is given as 0.2. Okay, now you have to find, so basically suppose this is the mean position, that is x equals to 0. The amplitude is at x equals to 0.2. They ask you how much time it will take to reach over here, which is x equals to 0.1. Now do not answer 12 seconds. Okay, even though it's midpoint, do not answer 12 seconds because it is not a simple constant velocity problem. This is an acceleration problem. So you cannot simply say that it will be 12 seconds. Then it will be wrong. Okay. How to solve this question? To solve this question, you have to know the equation of simple harmonic motion. Equation of simple harmonic motion is x equals to amplitude into sine omega t. Okay, amplitude equals to x equals to a sine omega t. So x for this is 0.1, amplitude is 0.2. Okay, now what about omega? How to calculate omega? So time period is given, so you can calculate omega. Okay, so omega is 2 pi by time period. Omega is 2 pi by time period. Time period is 2 pi by omega. If you remember, these formulas we have used in our magnetism chapter, where cyclotron frequency, angular frequency, time period, we have used these kind of formulas. Okay, even in AC chapter also we have used these formulas. Okay, so we are using these formulas, but sometimes when it comes to P1 chapters, no, we almost forget that, okay, this formula we have actually used. So same formulas, as long as it's a motion, a simple harmonic motion or periodic motion, the formulas are always same. Okay, so omega is pi by 12 and this is time. We are trying to find this time when x is actually equals to 0.1. Now let's simplify. So sine pi by 12 into t equals to 0.2 divided by just a second, it will be 0.1 divided by 0.2. This goes over here in the division. So what is this? This is half. Now what is the value of when the sine theta becomes half? Sine theta becomes half at 30 degrees. 30 degree means what? In terms of pi, it will be pi by 6. Pi is 180. So 180 by 6 is 30 degrees. Okay. So pi by 12t must be equals to pi by 6. Pi cancels and we get t equals to 12 by 6, that is 2. Okay. So correct answer is 2 seconds. It will be simply 2 seconds, not 12 seconds, but 2 seconds. Yes. Don't delete your messages if you answer wrong, don't worry. We also make mistakes. The ratio of kinetic energy to the potential energy of a simple, so you have to go through these chapters once. So if you see that some chapters is being done, if you really want to revise, just revise the chapter once, then you come and watch the lecture. That will be very, very beneficial for all of you. Okay, because we have already published the list of lectures which are going to come in next 3-4 days. Okay, so just follow that, and whenever you are revising with us, check the chapter that, suppose tomorrow is your math lecture. So during the math lecture, you check what are the lectures that is being done by Ankit sir. So check those chapter once, then come. So that will help you to understand what sir is teaching. Also, it will refresh your memories and you will be faster. The ratio of kinetic energy to the potential energy of a particle executing SHM at a distance equal to half its amplitude, the distance being measured from the equilibrium position. So distance is half of the amplitude. Now many of you, when you are in P1, you were familiar with these equations, but because you have not used them for one whole year, now you have forgotten most of them. So what is kinetic energy? Kinetic energy of an SHM is half m omega square into a square minus x square. What about potential energy? Potential energy is half m omega square simply x square. Okay, so what they have asked you? They asked you the ratio of kinetic to potential, right? Kinetic to potential. So kinetic to potential ratio is half m omega square cancel. It is actually a square minus x square by x square. Okay, or you can write this as a square by x square minus 1. Okay, divide this, you will get, right? So you have to basically, what you have to do, square both sides. X square is equal to a square by 4. Now divide this, cross multiply, you will get a square by x square equals to 4. Okay, so just put that here, you will get 4 minus 1. So basically it is 3:1. Very simple. If you apply the method, it will be very, very easy if you just remember the formulas and few extra tricks. For example, this is a trick. If you calculate, put the value a by 2 over here, a by 2 over here, you will get some value, you divide it. That will take longer time. But if you simplify in terms of variables, and at the last if you put the answer, it will be very, very quick. Okay, so this is a quick way to solve. This is a shortcut way to solve. This is the shortcut. There is no formula, no gimmick here. It is the way to approach a problem. How you approach a problem basically defines that how quickly you can solve the problem. Okay, again it is not option A, it is option 3. Okay, it will be 4 minus 1. Okay, 4 minus 1, there is a minus 1 there. Okay, a square minus x square. Now next question, the displacement of a particle executing SHM, the displacement of a particle executing SHM is given by x equals to 3 sine 2 pi t plus pi by 4, where x is in meters, t is in seconds, the amplitude and maximum speed of the particle is. So you have to calculate the amplitude and maximum speed. I will give you 2 minutes to solve this. I just need to get some water. My bottle is finished, so I'll come back in just 2 minutes. Okay, so sorry, I think question is changed. This is the question. This is the question that we are discussing. No, Manoj, we will complete it quickly. Okay, another 20 minutes we will finish it, and then we will discuss any doubts that you might have. Darshan is saying we might think it's B. Okay, let's see. So here, if you see that x equals to, the question is changed, sorry, somehow it got changed. So this was the question, x equals to a sine omega t plus phi. This is an equation, right? This is the standard equation of SHM. Here a gives you the amplitude. So you can see the amplitude is C. In fact, I don't know why they have given you this option amplitude. All the options have same amplitude because amplitude is fixed. What about maximum speed? Basically this question is asking you about maximum speed. The maximum speed is given by A into omega. Maximum speed of SHM is given by A into omega. So what is A? A is 3. What is omega? Omega, if you see that, compare this, you will get this is 2 pi. So 3 into 2 pi. So it is actually 6 pi meter per second. So the maximum speed is 6 pi. So correct answer is option A. Okay. Correct answer is option A. For particle executing simple harmonic motion at its mean position, velocity is 0. Now I think you have enough time to solve this question. Velocity is 0, acceleration is maximum. Velocity is maximum but acceleration is 0. Both velocity and acceleration are maximum. Both velocity and acceleration are 0. So here a particle is executing SHM. Okay. Now at this mean position, what happens? These are the extreme positions, this is the mean position. So remember that at the mean position obviously displacement is 0, and at this point when the particle reaches at the maximum position, obviously it comes to a rest, and because of the rest here velocity is 0. Velocity is 0. Now velocity 0 means it has to move back to its original position. So who is taking it back? Because acceleration is maximum. At the extreme position, both extreme positions, velocity is 0, acceleration is maximum. At the mean position on the other hand, here the acceleration is 0, okay, but it has to reach to the maximum point, so that means here velocity is maximum. Okay, so extreme positions, displacement is maximum, and that is equals to amplitude. Okay, and here displacement is 0, and at the extreme ends velocity is 0, acceleration is maximum. So from this we can say that velocity is maximum, acceleration is 0. Okay, not option A, Chetan. Sahana, we have another 7 questions. Okay, the variation of kinetic energy Kx, potential energy Ux, and total energy as function of displacement of a particle in SHM is as shown in the figure. The value of x naught is, x naught is nothing. What is x naught? This is x naught. Okay, this is x naught. So what is the magnitude of this point? Slight mistake is here. This is actually from here, this point. Okay, so what is this point? Okay, so basically when you plot kinetic energy and potential energy, okay, potential energy is maximum at the ends, kinetic energy is maximum at the middle. Okay, so this is also one more thing in the last question. Kinetic energy is 0 here, potential energy is maximum. Here kinetic energy is maximum, potential energy is 0. Same over here, kinetic energy is 0, potential energy is maximum. Now when these two lines meet, okay, at this point basically kinetic and potential energy are same, right? This axis represents the energy, so they are meeting at some point, means kinetic and potential energy are equal. Now if you forget the formula or derivation, okay, let me remind you that kinetic energy is given by half m omega square a square minus x square, and potential energy is given by half m omega square x square. So basically at these 2 points the y value is same. That means kinetic and potential energy are same. So K equals to U. So for x naught obviously K equals to U, for x equals to x naught. Now put the values, half m omega square a square minus x naught square equals to half m omega square x naught square. This cancels and we get a square minus x naught square equals to x naught square, or a square equals to 2x naught square, or x naught square equals to a square by 2, or x naught equals to a by root 2. So this is a small derivation that you have done in your PU1 class, that at x equals to a by root 2 the kinetic and potential energy are equal. Okay, So here kinetic and potential energy are equal at x equals to a by root 2. If you remember it, it's just a remembering problem. If you don't remember it, you have to solve it. Okay. Now next question. Two tuning forks A and B produce notes of frequencies 258 Hz and 262 Hz. An unknown note sounded with A produces certain beats. When the same note is sounded with B, the beat frequency gets doubled. The unknown frequency is. So here lot of different answer is possible, but this is one of the previous year problem, little older, but I don't remember the year. But to solve this, we have to assume that the frequency of the unknown fork. So basically what is the tuning fork? Those who remember, this is a device, right? Here we have like this. So this is A, this is B, and some unknown tuning fork is there, which is say C. Okay, so tuning fork, if you hammer it, it makes sound, right? You have done some experiment in the laboratory in your P1, right? Now the question is, these two are making some beat frequency. What is beat frequency? Suppose this frequency say F1, this one is F2, this one is F3. First of all, the beat frequency is heard when the difference in frequency is very small, less than equals to 10 Hz. Suppose this is 100, this is 200, they will not produce any beat. Okay, beat is the same thing that you hear in the music. Okay, you say give me the beat. What is the beat? Beat is actually the difference in frequency. So two frequencies are present in the sound, and because of their very closeness, they produce a unique sound effect. That is called beat. Okay, so this is 100, and suppose the second one is 110, this one is say 105. Suppose, okay, then it will produce beat. This between these two, it will produce a beat frequency of 10. Between these two, it will produce a beat frequency of 5, and between these two, it will also produce a beat frequency of 5. So beat frequency is basically difference in the frequency. Beat frequency is basically difference in the frequency. Now obviously you can take, if the difference is given, suppose I say that this one is 100 and this one is producing a beat frequency of 5. So this one could be either 105 or 95. Both can produce a beat frequency of 5 with this. So that is a trick about beat frequency. Sometimes in the question they will mention that we add some mass, the beat frequency increases or decreases. Those kind of hints will be given. In this case it is not given, so we will assume that the unknown frequency is less than 258. The unknown frequency is less than 258. Okay, unknown frequency is less than 258. So that means the first case, the beat frequency F1 is given by 258 minus F. Okay, the beat frequency for case number 1 is 258 minus F. Now it says that there is one more device is there. Another one is 262. So what is the beat frequency 2? Beat frequency 2 will be 262 minus F. Obviously, if it is less than 258, it will be 262 minus F. Okay. Now it says that when same is sounded with B, the beat frequency gets doubled. That means F2 is twice of F1. Okay, beat frequency initially, suppose whatever the value was, it gets doubled for the second case. So beat frequency is doubling, means F2 must be twice of F1. So 262 minus F equals to 2 into 258 minus F. Okay, now simplify 262 minus F equals to 516 minus 2F. Okay, so this comes over there, this goes to over there, so we get 2f minus f equals to 516 minus 262. So it will be f equals to 11 minus 6 is 5, and then it will be 5 minus 3, that is 2. So 254 Hertz is the answer. 254 is the answer. Okay, now if you take a different value, we will get a different answer, but that answer is not part of this particular question, so we are not discussing that. Another one will be 259.33. if I remember correctly, 259.33 will give the same answer if you solve it. Okay, but that is not included in this question, so we will ignore that. A wire under tension vibrates with fundamental frequency of 600 Hz. If the length of the wire is doubled, the radius is halved. Okay, sir, are these PYQs? Yes, Pandavesa. Okay, some of the questions are slightly older, the year is not mentioned. Some 20-25 questions also years are not mentioned. Otherwise all of them are PYQs, in syllabus PYQs. There are some PYQs which are now not part. Those who are, for example, Doppler effect used to be very popular question, but Doppler effect is no longer part of the syllabus, so we have excluded Doppler effect related problems. Okay, a wire under tension vibrates with fundamental frequency of 600 Hz. If the length of the wire is doubled, the radius is halved, and the wire is made to vibrate under 1/9 of the tension, then the fundamental frequency will become. So frequency of vibration in a stretched wire means guitar, okay, then Bina, Tanpura, they all uses stretched string. If you pluck it at some point, it makes sounds, right? So what is the formula for that? Formula for that is 2L square root of tension divided by mass per unit length. Okay, now if you see that here, mass per unit length is not given, but radius is given. So what is the relation? Tension is given, tension is reduced to T/9, length is obviously there. What is the relation with mass per unit length with radius? So first of all, let us understand. Suppose the total length is L, mass of the total wire is M. Okay, the cross sectional area is A, which is equals to pi r square. Okay, now what is that mass of this string? Suppose the density of the material is rho. This is something important. Once the formula is derived, you can use the formula, but first let us understand the formula. So what is mass? Mass is area into length, that is volume, into density. Area into length into density. What is area? Area is pi r square into length into density. This is mass. Now what is mass per unit length? Mass per unit length is mass divided by length, that is pi r square rho. Okay, this is pi r square rho. Now if you put that over here, you will get 1/2L square root of T pi r square rho. So that is 1/2 root pi rho, okay, T by RL, square root of T by RL. So the frequency of a string is actually proportional to square root of tension by radius into length. Okay, so this is the formula that we will be using. Now if you remember, if you know this formula, it will be easier. If you don't know, you have to find it out. You cannot ignore the radius thinking that in the formula radius is not there. Radius is actually hidden inside this quantity. This is a little tricky question. Okay, so F2 by F1, we are trying to find F2, second case, frequency by F1 equals to square root of T2 by T1 into, they are in division, so it will be reversed, So R1 L1 by R2 L2. Okay, so remember, if some quantity A is proportional to say x by y, okay, then A1 by A2 equals to x1 by x2 and y2 by y1. Okay, you can simplify this and you can check that out. So whatever in the top, they go the same way as the quantity. Whatever is in the division, they go in the opposite way. Okay, this is a shortcut way to remember. These techniques help. This is a technique. You cannot always write root T2 by R1 L1 by root T2 by R2 L2 and then take the process. Okay, this will save you time. This process will save you some time. Now what is T2? T2 is 1/9. Tension is 1/9. Okay, 1/9. Tension is 1/9 of the first case. So T2 is 1/9 of T1. Okay, what is R1? Okay, the length of the wire is doubled. Length of the wire is doubled. That means the L2 is 2L1. Length of the wire is doubled. The radius is halved. Radius is halved means R2 is half of the radius. Okay, so R1 L1. So 2 cancels. R1 L1 cancels. So basically this one actually cancels. Only thing that is left with is 1/3. Okay, tension cancels. Only 1 square root of 1/9, that is 1/3. So frequency 2 will be 1/3 of frequency 1, that is frequency 2 will be 1/3 of 600, that is 200 Hertz. Now many of you find this question little difficult because maybe you have not solved a lot of questions, but if you start solving these questions, it will come to you naturally. A pipe of 30 centimeter long, open at both ends, produces harmonics. Which harmonic modes of the pipe resonates at 1.1 kilohertz source? Given the speed of sound in air is 330 meter per second. Okay, so now open pipe, closed pipe. What is the formula for frequency of nth harmonic in a open pipe? Open pipe, whatever is an open pipe, closed pipe is half of that. Okay, so open pipe, it is n into speed of sound divided by 2L. L is length. So suppose this is an open pipe. Pipe means flute. Those who have seen flute or played flute, okay, flute is a device. Okay, Chandramouli is saying option B for the last question. No, it is wrong. Next, again, make sure you calculate it properly. This one we have to check. Now mention the question number, guys, so that I know which question you are answering. So for open pipe, both side is open. Okay, if you put sound on a pipe, if you blow air, it makes sound also. Okay, the flutes are specific device which actually uses this physics. Open pipe means both side is open. Closed pipe means one side is closed. Okay, and remember, if fundamental frequency is nu m for open pipe, then for closed pipe, for one end closed pipe, it will be actually half of the open pipe. So it will be NV by 4L. Okay, one you remember, another one will automatically come to your mind. Now it says that it is resonating with 1.1 kilohertz. Resonating means it is exactly the same value. Kilohertz means 10 to the power of 3. Resonate, one object resonate with another means the value is exactly same. So this will resonate only if this frequency matches with this. Okay, now we are trying to find this value of n. Okay, so n is given. Now length of the pipe is given 30 centimeter and speed of sound is given in meter per second. So you have to convert the unit. So n we are trying to find, velocity is 330 meter per second divided by 2 into 30 centimeter. Centimeter to meter means 10 to the power of minus 2. 0 0 cancels, it becomes 11, and you get n by 2 into 11 into 10 to the power of 2. Okay, this goes up, becomes plus, equals to 11 into 10 to the power of 2. Now if you take this 1 0 from here, it will balance so that we can cancel. Okay, so 1.1 into 10 to the power of 3 means 11 into 10 to the power of 2. So one of them will cancel. So n by 2 becomes 1, that is n equals to 2. So it will be second harmonic. It will be second harmonic. Okay, one simple formula can solve your problem. Yes, correct, Chetan. Next question. The waves set up in a closed pipe are longitudinal and progressive, longitudinal and stationary, transverse and stationary, transverse and progressive. So what is the longitudinal and transverse? Transverse is this. Okay, so when the wave travels like this is called transverse. And what is longitudinal? Longitudinal is like this. Okay, this, if the sound travels like this, this is called longitudinal wave. So particles vibrate. If the particles are vibrating in the perpendicular direction of the wave motion, then it is called transverse. But if the particles are vibrating in the same direction as the wave progression, then it is called longitudinal. Okay, here for example sound wave is a longitudinal wave. Here it is called compression, and this is called rarefication. So basically the air particles are vibrating like this. They are compressing at some place and they are expanding at some other place. Compression and rarefication is the process through which longitudinal wave moves and transverse wave moves like a wave. Okay, so in a closed pipe basically is a sound instrument. Okay, sound instruments always are longitudinal. Okay, longitudinal. And it is one more important thing is it's an instrument, so all the instruments always produce stationary wave. All the instruments including guitar, veena, tanpura, whatever instrument are there, they always produce stationary wave. So it is a longitudinal and stationary wave. If the question is based on guitar, any string instrument, guitar, tanpura, veena, then it will be transverse and stationary. Okay, guitar, tanpura, veena, they all produce stationary waves, but stringed instrument produces transverse wave because in the string the sound wave vibrates like this, so they are transverse. In any air based instruments, okay, they are always longitudinal. Clear? Now next question. To propagate both longitudinal and transverse waves, a material must have bulk and shear moduli, only bulk modulus, only shear modulus, Young's and bulk modulus. So longitudinal and transverse wave. So what is the type you need for longitudinal? Longitudinal means, as I mentioned, at some region it will be compressing, some region it will be expanding, and compressing and expanding happens through what? By compressing the volume. Okay, it is happening through the volume obviously. So volume gets compressed, volume gets expanded. So compression of volume means it must be bulk modulus. So bulk modulus must be there for longitudinal wave. So longitudinal wave always have bulk modulus. This is longitudinal. What about transverse? Transverse is this. So transverse, this means it must have, you are applying a force, it is, the force is applying tangential to the wire, right? So it must be shear modulus. Okay, air has bulk modulus. Air does not have any Young's modulus or shear modulus. String on the other hand have bulk modulus as well as shear modulus. So string can produce longitudinal as well as transverse, but most of the string instruments are transverse wave. But if a material can carry both type of wave, it must be having bulk and shear moduli. It must be having bulk and shear moduli. Bulk means volume, shear means tension. You can say tension is shear. Next, the angle between particle velocity, last question of the day. So let's hope that you are all done. Chetan was saying option A. Yes, correct. Now next, last question, answer this question. I will see who can answer this. The angle between particle velocity and wave velocity in a transverse wave is, except when the particle passes through the mean position. I don't know why they have given this exception. Question came in 2025. So if you know this very easy question, if you don't know this, it will be very difficult for you to answer. Angle between particle velocity and wave velocity in a transverse wave. So in a transverse wave, what happens is that particle vibrates in this direction. Okay, particles are vibrating in this. Okay, particles are vibrating in this direction, and wave is propagating in this direction. So if you remember, all of us have did that in the past. We take a stone, we throw it in a water, okay, and the rings slowly go out, right? So this is a transverse wave. That very beautiful curve happens on the water is actually due to transverse wave. So what happens is that the circle size increases is actually the wave propagating outside, okay, and that small thing that happens in water is actually because of the up and down motion of the water particles. Okay, so particles always vibrate in the perpendicular direction of the motion. Particles are vibrating like this, and wave propagate in the perpendicular direction of this vibration. So the angle here is obviously 90 degrees, which is pi by 2 radian, option B. So if you just know this, you will be able to answer this question less than 10 seconds. Okay, maybe 20 seconds if you waste a little time on thinking. Yes, no Chetan, not option A. Pi by 2, pi by 4 cannot be answered. Remember, most cases either pi by 2 or pi or 0. Okay, general cases, if it is related to a problem, if you have to solve it, then it can be any angle. Okay, for example, in cyclotron motion in magnetism, okay, so if the angle is 90 degree, it will rotate in a circular motion. If the angle is 0 degree, it will move in a straight line. If it is moving in a helical motion, okay, which is neither circular nor a straight line, mixture of both, then the angle can be any value between 0 and 90, right? So that is the case. That was a special case. 0 and 90 angle pi, that is 180 degree, they are all special angles. Okay, in this special case, they will be the answer, not a common angle such as pi by 4. Okay, so remember that. Okay, so even if you have to guess, you can guess most probably pi by 2 will be the answer. Okay, so this is the end of this lecture. Now, if you have any doubt, please sir, when is second PU live class, sir? From next class onwards, second PU we will start. Okay, this is the end of PU1 lectures, PU1 chapters. All the important questions of PU1 are discussed. From next class onwards, we will start PU2 chapters. Okay. Now, if I remember, someone asked the important chapters of PU1, distortion. I think if I remember, distortion was asking. I think he left the class now. Okay, distortion or destroyer. He was asking what are the important chapters of PU1. Now remember, Importance means those chapters are fundamental chapters. Fundamental chapters means you will be able to the concepts that you are learning in those chapters will be carried forward in your PU2 chapters as well, and in sometimes PU2 chapters also they mix concept from those chapters. The chapters which I recommend is units and measurements, not because questions will exactly come from this chapter, because this chapter has a long application in the other chapters where you are solving some dimensions, some units. Okay, that is why it is important, not because question coming directly from this chapter. Concept of this chapter will be used. So if you just want to study the concept, go through the NCERT summary of all these chapters I am mentioning. You don't need to study the entire chapter, read NCERT summary. Okay, and our master stroke for PU1 will resume soon. Don't worry, you can revise from there also. It will not be very long lectures, short lectures. You can revise from there as well. So units and measurement. Next is motion in motion in a straight line, motion in a straight line, or motion in 1D, motion in 2 dimension, or motion in a plane. Next is laws of motion. All motion you have to study. Next is work energy power. Next is gravitation, and last system of particle. But this chapter is optional. If you these chapters are important because from these chapters you get 2 questions. Okay, now obviously these chapters are fundamental, very fundamental, including work energy power as well. Gravitation and system of particles are important because from these chapters you get 2 questions each. Okay, now system of particles, if you have not studied before, you can skip that. At least read the NCERT summary, and remaining you can skip. Okay, because system of particle can be tricky if you have not studied that chapter. For example, that question came in 2025. Even if you have studied, you may not be able to answer that question. That was tricky, very tricky question. Okay, one question was easy, one question was tricky. So at least read the summary, so that if you see a easy question, you should not miss out on an easy question. Okay. Okay, so this is the end of the lecture. If you have any doubt, any more questions, any doubts, please mention that in the comment section of this video. I will gladly help you out with all of your doubts. Till your next class, bye and see you.